This is our first time officially graphing something that is not linear, and the nonlinear graph that we're going to be looking at in this lesson is called an exponential function. And you might understand that exponential functions will include an exponent, and the exponent in this case, if this is our function y equals ab to the x, the exponent is our independent variable, which is the value of x. A would just be a constant, or C, it would be a coefficient. B is the base, and Y would be what you get when you plug in your values. In Chapter 5, we talked about linear relationships and how linear relationships have a constant difference. In exponential functions, we have what's called a constant ratio. And remember, with our arithmetic sequences and our linear functions, we said addition and subtraction are really the same thing because it's addition of a negative. So division and multiplication will be the same thing because it will be multiplication of a fraction. So what do I mean by that? Let's check out example 1. We have to determine if something is linear, meaning constant difference, or exponential constant ratio. So as you go through your table, you see that the relationship between the y's is plus 2. So since it's a constant difference, then letter A is linear. Letter B, on the other hand, is not plus 4 every time or plus 8 every time. It's actually multiplied by 2. And so since it's not addition or subtraction, since it's multiplication, this is what exponential would look like. All right, I'd like you to pause the video and try C and D on your own. All right, I changed this to say plus -1, so that way you could see that it is a constant addition every time, whereas this is a constant multiplication where it's being multiplied by 1/2. We always think of the ratio as what you're multiplying by, so if it's a division, figure out a way to write it as multiplication. We're still kind of introducing exponential functions. Now we're just going to simply evaluate. So this is just order of operations. So let's check it out. And remember, you're going to use that exponent key that we talked about that either looks like this, it could look like that, or it could look like that. Those are your exponent keys, and we talked in class about how to use that. So we're going to use that right now. First thing I have to do is rewrite this equation, but instead I'll write 3. So y equals -2 parentheses 5 to the third. And the parentheses are there to represent multiplication. So I have multiplication, and I also have exponents. So remember, exponents come before multiplication in order of operations. So it's going to be y equals -2. And when you use your button, 5 to the third power, 5 times 5 times 5, is 125. So that gives me that y equals -250. Now we go to the second one, same thing. I'm going to plug in -2, 3 times 0.5 to the -2 power. Now I'll show you in a second how to do it if you don't have a calculator. But first, let's calculate, assuming that you do, and you have that key that we talked about on the scientific calculator. 0.5 to the -2 is 4. And so you get y equals 12. Now, if you don't have a calculator with you, you should, because I told you that you need one for this chapter. You could do it without one like this. You could turn 0.5 into a fraction and do y equals 3 times 1/2 to the -2. And remember, negative exponents mean to do the reciprocal. So you get y equals 3 to the 2/1 to the +2 exponent. Well, that's just 2, so y equals 2 squared, which is 4, and so you see you get 12 regardless, but obviously with the calculator it's quicker. All right, why don't you try letters C and D on your own. Hopefully you match. It doesn't matter to me whether you used a calculator or not. I did it without a calculator. If you did it with a calculator, that's fine. And now we're going to take our exponential functions and graph them. So we have to go pretty slow the first time because this is your first experience graphing something that is not linear. So we plug in, right? Anytime you're not sure how to make a graph, you make a table and you plug it in. So first, here's my equation, y equals 2 to the x. And wherever I see an x, I'll plug in the values that they give me here in the chart. So I'll use this area right here as my workspace to show you my plugging in techniques. If you don't need this space, that's fine. So first thing I'll plug in is -2. That's 2 to the -2. So I know that that is the same as 1 over 2 squared. So that's 1/4. Now I will write it as 1/4. You could write it as 0.25, but I would prefer a fraction. Now we go to the next one. Y equals 2 to the -1. Well, I know that that means y equals 1 over 2 to the +1. Well, duh, 1 over 2 to the 1 is the same thing as 1 over 2. So now let's move on to the 0. Well, anything to the 0 power is 1. So that's 1. And the next three should be pretty straightforward for you. That's 2. That's 4. And the next one is 8. So now you plot your points. -2, comma 1/4, -1, comma 1/2, 0, 1, etc. Now estimate where your points were. Obviously you can't exactly get at 1/4, but you can approximate where you think it is. So -2, 1/4 is pretty close to the x-axis. So I'll plot it right there. -1, 1/2 is about here. 0, 1. 1, 2. 2, 4. 3, 8. And you see, obviously, this is not linear. And just like we would extend it on linears, we also extend it here as nonlinears. And what I want you to realize is that this will never cross over the negatives. This will never get, oh, I didn't connect that well. This will never cross over the x-axis. There's nothing that you could plug in for x, and you can try if you don't believe me. There's nothing you can plug in for x that would give you a negative answer. So you don't cross over the y-axis, and you'll get more familiar with that as we continue to do more of these, and then you write the equation on the curve. And that's graphing, and now we just have to describe the domain and range. So the domain, I'm going to abbreviate with the D, is all real numbers. But the range is any value that's greater than 0. Now, it's not allowed to be equal to 0 because we have this spot right here where it actually never touches 0. So it's that y is greater than 0 because all of the values on the graph exist when you're in the positive y values, but not in the negatives and also not at the 0. Okay, I'd like you to try example B. Pause the video. I'll do it while you've paused. The only difference between the last one and this one is that after you do your math down here, you're then going to have to add 3, so it will be a little higher. All right, now as you can see, the last dot, 311, actually didn't fit on my grid. When you're graphing any sort of function, really, you should always make your table before you make the grid, because if you see, I have this big empty dead space down here, and all of my graph is up here, and I actually ran out of space. So we're going to see in a moment why it's very helpful to have the chart before you make the axes. Don't just make the big plus sign before you know what your points are going to be. See, now for this one, what I've done ahead of time is I didn't make the coordinate graph because I, want to know what my values are before I go plotting, because exponential functions, like we've mentioned before, they can get quite large. So the first one I want to do is -2, so 1/2 to the -2 means to flip the fraction, and that's 4. 1/2 to the negative 1. When you flip it, you get 2. 1/2 to, well, anything to the 0 is going to be 1 if it doesn't have a coefficient or a addition or anything. Anything to the 1 is itself. That's 1/4. And that's going to be 1/8. All right, so I do need to include negative x values, but I don't necessarily need to include any negative y values. So this is a setup that I don't know if we've ever used before, where I just need the positive y value. So I'm going to set up my grid like this. You can set it up however you want, but this is how I'm choosing to do it. And now I plot my points. And you see that flat lining now is happening on the other side. Okay, so there's what I've got. I plotted my points and I connected with that smooth curve. And now we have to also describe the domain and range. Again, for the domain, we really can plug in any real number that we want. And for the range, it's going to be that the y values are greater than 0. Again, they're not equal to 0 because we have that flat line portion. And let's check out the next one. Okay, so I'm not going to show the work for letter C, graph y equals -2 times 1/4 to the x. I'm just going to put the numbers in the chart. So pause the video, just see if you can fill in your chart, and then pick up with me. Okay, so there's my table. Hopefully you got them all correct. And now we have to plot. But as you can see, we have to go to -32. So we really only have to include the negative y values, but we have to include both positive and negative x values. Okay, so then the question is, what's our scale? And it looks like I can make the y's go by 2. I think I can fit everything in there if I go by 2 on the y's. So I'm going to stop numbering there, but obviously it would continue. So now I just plot my points and then I connect my smooth curve. So I keep getting closer and closer to the x-axis, but I don't touch it. There is not a number that you can plug in that will give you a 0 answer. And there's my graph. And let's finish up on the left before we do the domain and range. Actually, we can do the domain and range now. For the domain, I can plug in any real number that I want. And for the range, we're just looking at the values that are less than 0, not equal to 0 because we have that flat line portion where it never crosses the 0 or touches it. All right, so now let's go over to the side where it says what is the y-intercept and where do you see this value in the equation. So look at the y-intercept, which is here at -2. And now, where do you see -2 in the equation? -2 is right here, kind of like the coefficient. If you think back to our formula, which was y equals ab to the x, the -2 is in the a spot. So if you think back to linears, our y-intercept was our b value and our slope was our m. And then x and y were just part of the formula. This is very similar. What we have is the number in the a spot is our y-intercept. So there's -2 and there's -2. And then the 1/4 represents that constant ratio. So if you look in the table, everything's getting multiplied by 1/4. So the skills that we learned when we did y equals mx plus b have the same kind of idea, only now we have the a and the b representing the y-intercept and then the common ratio. And then obviously x and y are just the x and y axes, so you leave those in the equation. In this question, we use what we just talked about 5 seconds ago, y equals ab to the x, to write an equation based on a graph. So we can do it for linears, we just need the slope and intercept. And here, we don't need the slope and intercept, what we need is the y-intercept and the constant ratio. So the a value is the intercept, which in this case is 0.3 right here, it's listed. And the constant ratio is what you're multiplying by every time you go up a value. So let's see if we can figure it out. 3 turns into 12, which turns into 48, which turns into 192, which turns into 768. So what are you doing to go from 3, 12, 48? Well, you're multiplying by 4. So the constant ratio is 4. So let's just put it all together. Y equals 3 times 4 to the x. And there we go. That's letter A. I put in the wrong spot. And find the population after 12 hours and also after 5 days. So we have to pay attention to our label. The X stands for days in the graph up top. So this would be half a day. And then this is obviously 5 days. So it's asking us two different questions, and I'm going to use my formula that we just discovered to answer this question. It was y equals 3 times 4 to the x. So let's plug it in for half a day. Y equals 3 times 4 to the 0.5. Oh, actually, I'll write that as 1/2 so I can use my skill. So y equals 3 times. Fractional exponents mean that's the root. So y equals 3 times 2. So there would be 6 bacteria. And now let's check it out with 5 days. Y equals 3 times 4 to the x. So in this case, x is 5. So I'll get my calculator for that. That's 1,024 times 3 is 3,072 bacteria. If you have any questions, write them down and ask me when you come to class.